Hi, this is Ryan again. I'm going to be making a bearing idea I had for a little while ago. We were looking at linear bearings, the LMU or LM88Us or something like that. What they are three rows of bearings. Here, I could pull one up real quick for you if you'd like. LMU88. That's it. That'll pull up something at least. While that's going, I'm going to kind of tell you where I'm going to start. I'm actually going to use a iterator function, a for. So it's going to be using it to LM8UU bearing pack. So these. Right there. There are three rows of bearings in a plastic sheath and surrounded by a metal pipe. I was thinking I could print something like that. Do a little bit of machining on a metal tube. Maybe make a lip and use some snap rings to keep it in and see if that works. So, again, I'll go back to this. We're going to use an iterator function. We're going to use for and something similar to this, for I equals 0, 5. But I'm probably going to use like for I equals 15 and then a colon, a 10, and then maybe to 30. That doesn't seem right. That's too little. But yeah, that's just a general idea. But it's a bearing. It's a very simple bearing idea. So we're just going to start with a cylinder that we're going to end up differencing. But I like just seeing it and working at a point by point. Let's make this actually kind of accurate to spec. The LM8UU is the LM is long something, and then that 8 is the inner diameter. So we're going to have the radius of the exterior be 10. 10 sounds like a good number. And if I actually thought and typed, so the radius will be 10, height will be, let's go with 30. 30 sounds like a good, nice round number. And then semicolon. Always remember the semicolon. That looks like a nice bit. And then we're going to do a difference. We're going to difference that cylinder. Not that cylinder. We're going to difference from that cylinder. And that cylinder is going to be radius of, I forget, radius, not diameter. So that radius is actually going to be 5. And this radius is going to be 4. Because that LM8, that 8 stands for the diameter. And an M8 rod will fit through that. And that height's going to be exactly the same because it's going to go straight through. It's going to be a straight bore through the pipe. And then we do our finishing curly bracket and hit F5, and it does absolutely nothing. Why does it do absolutely nothing? What did I do wrong? I know what I did wrong. I didn't. No? No, something's wrong. H equals 30, difference. Let's check something. Difference. Cylinder rotation. We're going to go to view. And we're going to show. Let's try GCalc grid only. Right now, you'll see that we're going to actually comment out that difference. I see my issue right now. I misspelled cylinder. Spelling matters a lot, as you can see. So we hit F6, And we're going to get a nice round bearing. That looks more like a bushing start right now. Those walls seem kind of thin. If we're going to insert, you know, millimeter size bearings. So I'm going to hit here and go to 6, bring it up, F6. So that seems a little bit beefier. I like that a little better. Okay, so what we're going to need to do is start a row up there and just get the bearings embedded into that wall. So what I'm going to do is just make it work and then difference it from that object. So we're going to go back to that 4 and just get a good understanding on how that works. So again, we're going to do 4 parenthesis I equals height of 30. Let's do I is 5 increment of 5, and it's going to go to 25. So what that's going to do is it's going to start at 5 millimeters up, and every 5 millimeters is going to be a instance of another sphere. So then we're going to close off that, add a parenthesis, and is there anything we have to do for that? There is. We're going to have to do a curly bracket, and then we're going to have to do a translate 0, that's a O, not a 0, 0, 0, and I. And then we're going to do sphere. And what's a good size for ball bearing? We did a 8 and 12, so that's a 4 millimeter distance. Let's do a ball bearing of 1 radius. So it'll be 2. That'll be a fairly beefy bearing. You can just leave that like that, and it should generate a sphere. And there we go. So what happened there? Translate. So right now that's only 1. So I think this is what happened. This is exactly what happened. I forgot the square brackets. The square brackets are important. F6. So now we turn that, and you can see there's like 5 in there. There should be 5, I believe. We're going to go to grid only. The contrast is kind of crappy, but you can see a little better that there's 5 in there. 1, 2, 3, 4, 5. Now what we're going to do is we're going to translate it into that wall. So I'm just going to redraw it real quick. With an F6, that's the what does F6 do again? It redraws it in a different form. F6 draws it in a compile and render with CGAL. F5 just compiles it kind of dirtily. So we've got that. They're sitting at the center of the axis where X, Y, and Z meet. Well, kind of. They're sitting on X and Y's center. This is a radius of 4. So if we move either the x or the y by 4, we should intersect with the wall, with the sphere. So we're going to do y. Hit F5, hit F6, get a better drawing. And you can see they're now embedded into the wall. Those should stick in there if you just insert them while it's printing or when it's designed. There should be more than enough in there. I'm going to just do like a 4.2, F6, and that's perfect, I think. They'll be in there, will fit. Ooh, I see an issue with this actually. My issue that I see right now is that it's not going to be an 8mm space. It's going to be a 8mm minus the radius of the sphere and, you know, whatever is taken out for that little translation I did. So it'll be like 1.8. It'll be 0.8 millimeters too small for an 8mm rod to go in there. So if I hit 5, is that right? No, that's not right. It'll be 1.8 millimeters small because it's a 2mm sphere, or a 4mm diameter sphere. So if I hit F6, and we're going to bring this up to 7, so that's 14. And there we go. That's a little better. And I forgot to change these numbers. Let's go 5, F6. And there we go. So this is 10 minus 2, which is 8. So these will actually, I think if my math is right, fit a 8mm rod. So now that we have this done, what we're going to do is we're going to rotate these, and I'm just going to constrain it in 3 ways. So it's just going to rotate everyone for 120. I believe I can capture this in here, and I'm just going to tab it over. I wonder, how's this going to work? Well, let's see if this works. If not, I can cheat and be lazy. So I'm learning while you're learning. It's not ideal, but it happens. 120, and it's going to max out at 360. And I forgot those square brackets again. The square brackets seem to define a exact rotation. I'm going to try this. Rotate. Because if this doesn't work, I can do a... I'd have to reassign the... Oh, crap. I'm going to take the lazy way out of this, actually, right now. So what that means is I'm going to add a rotate in here. And rotate it around the z-axis, I believe. This one doesn't have to do it, actually. This one does. Rotate. $120. And that'll be F6. Takes a little longer to generate, but you see it's about 120, and then I'm going to do it again. I'm actually just going to copy this and make it a negative rotation. And that'll be where I want it. F6. Yay, trig coming into use. So there, that'll actually cover that and work. My only problem is there may be an issue with the bearings not sticking in. I'm not entirely sure. I don't believe that should be an issue. But the issue I had with this was I was going to try to contain a 4. Actually, I don't even need to do this. I could do this all in one thing, I believe. I could. I'm going to do that. But I'm going to be smart about how I do it. I'm going to hit that, tab V. And then I'm going to do, I believe it's Control D that comments it out. Yep. F6. I can. So I can be a little lazy on how I do this. So this works. There's probably some math I could do that would make it work internally. I know there is. I just don't know it off the top of my head. I don't usually... I have a kind of dirty work process that I'm slowly refining. Trying to make it a little speedier to generate. And here we go. Yeah, there we go. It just makes the code a lot easier. But the issue was there's I equals 5, da-da-da. Well, I is that. And I used I for that. I was going to use I's for that rotation. I think I can use other variable. I know I can use other variables. I just didn't. I was afraid it was going to make it messy. But yeah, this is the object. It's right here. Kind of sloppy. Oh, I haven't done this yet. And I'm going to do another difference. And F6 to get rid of those bearings. And I'm actually going to up that resolution for those holes. So that's going to be a comma $FN equals 10. I think 10 is a fairly good one. We're actually going to test this out real quick, see how it comes out. Takes a little bit of a significant, or a decent amount more time to generate the code. It looks 10's not bad. That's the one. So yeah, I'm just gonna up these all to 10. I'll go 15. And we're just gonna copy this and overwrite all these. F6. And take it a little longer, but hey. Alright. It's taking a bit longer than what I was expecting. But this just makes it a smoother part. And this is where it needs to be smooth. The larger parts aren't going to touch the rod at all, but the bearings are. And it's also where the bearings are going to touch the sleeve. So the better finish you can get on the bearing ports, the better friction reduction you can get on the rod. There seems to be an issue with the spheres coming through. Translate 5i. Rotate 120. Translate. That shouldn't affect it. So I'm just going to bump the outer to 7.5, not too much more material. These are kind of chunky, but they're an incredibly useful functional piece that may serve to lower your cost, I'm not sure, of building a 3D printer. I kind of obsessed with building them. But yeah. If you have any questions or comments, post them below. You can also send an email to baslasks@gmail.com. Thanks for watching, and have a good night.